Aloha, welcome back again. So here we're going to get introduced to domain and range of a function. Now these words correspond to words that we've already heard before, so now we're just giving them another name. The domain of a function is a set of all possible input values, and we call that the input values are x. So anything that can be plugged into a function, that's your input, that's your x's, that's called your domain. All three of those mean the same thing. The range of the function is a set of all possible output values. So what can I get out? Blue's what you put in, red's what you get out. Look at that. Now what we're going to be doing is we're going to be identifying your domain and range for different graphs of functions. And the graphs are going to be looking different. But we kind of have two kind of setups here. So if you are given a set of points, what you should do is you should reply with a list of values. So if you're looking for domain, you're just going to list out all of the x values. If you're looking for range, you're going to list out all of the y values. If you are given a line or a curve or of some sort, well, we have two different options for us to reply our answer. We can either reply with an inequality, or we can reply with something called interval notation. Now, how you reply is going to be completely dependent on you. I'm going to show you both ways, and you can pick and use either way you want throughout the class. Me, personally, I prefer interval notation. Mr. Kennecke, on the other hand, he prefers inequality, to use an inequality to represent our solution. Mr. Frost, he prefers an interval notation. Mr. Klarner prefers an inequality. To each their own, as I always say. So we're going to practice writing both. You can choose which one you would like to use. Let's see here. The next thing. Since the domain looks at the x's, when we get a graph, this is going to be kind of like your help here. We are always looking at our domain and our range from a standpoint of low to high. So if you are given a line or a curve, this is what this is for a line or curve. Domain is on the x-axis. Ask yourself, how far to the left does my graph go? And how far to the right does my graph go? So you're always looking left to right. For our range, since that's the y's, you're asking, it's always going from low to high, so how far down does my graph go to how far up does my graph go? Let's go through some examples. So here is the first one. I guess I didn't label this as 1. We're going to call that 1. Problem 1. So what we are given is a finite set of points. I got 4 purple points here. And the first thing I want to do is figure out what the domain is. So the domain, again, are the x values. So what we want to do is list out every single x value that gives us a point. Well, if you don't know what they are, one thing you can do is you can write out what these points are. This is the point, -3, 2. You guys agree? Get out of here. This is the point, -1, 0. Ooh, this is the point, moving over 1, going up 2. And this last one looks like 2, 4. So if you're given a bunch of points, just write out what the ordered pairs are for all those points. And then in order to find the domain, all you're doing is you're making a list of all the x values. So here I like to put them in curly brackets. A curly brackets represents that you have a set of numbers. A set is like a collection of numbers. And here we're listing all the x values. I got -3, I got -1, I have 1, and I have 2. So those 4 numbers are all of the different x values of my points. And they correspond on the x-axis like that. The range, flipping around, is all the y values. So what do I have for y's? I got a 2, a 0, I got a 2, and a 4. So I got 2, 0, I got another 2 and a 4. So another way you can think about this is, imagine this is a list of my favorite numbers. I don't have to write 2 twice. I'm definitely not going to take off points if you write 2 twice, but as long as it's in your set, you're good to go. My favorite numbers are 2, 0, and 4. You don't have to say 2, 0, 2, and 4 again, but there you go. So you're basically just listing all the y values. Remember the y-axis is this one, so yep, that's that. That's that. This is 0 right there, and then we got 4 up here. So when you're given it as a set of points, a finite set of points, you can list it out as a finite set for that. For the next graph, you see that there are some highlighted points. That's just me telling you what those point values are so you can see them. But here we're actually looking at the full structure. This is one continuous curve, if you will. Oh, I messed up. There we go. So it goes from here down a little bit and back up. So for domain and range here, domain is looking at the x values. That's your left to right. How far to the left does my graph go versus how far to the right does my graph go? So what I did was I created these little vertical bars here. So blue for domain, because the domain is coming across different x values, -8, -7, -6. Oh, and as soon as I get to -5, that's where I hit my graph. So the furthest to the left my graph goes is -5 on the x. And the furthest to the right my graph goes, 4, is 3 right there. So my whole graph on the x-axis is in between -5 and 3. So it's between -5 and 3. So now what we, get a little tripped up there. So now what we're going to do is we're going to figure out how to write that in our two different forms. So the first form is inequality form. So if you want to write it as an inequality, it's going to look something like this. -5 is my low. That's less than my x, which is less than or equal to 3. So that's what it looks like as an inequality. -5 is less than or equal to x is less than or equal to 3. Actually, hold on. Let me see if I can write that in a different way. I think this will make it look nicer. -5. I do have one less than or equal to x less than or equal to 3. Let's delete this if I can. Thank you. And then let's grab this puppy and let's move it in. So this is how we look at this as an inequality. A lot of teachers like that. Not so hot on it. I prefer interval notation. Interval notation is legit just putting them in there. The lowest is -5, the highest is 3, and we're done. Now the only funky thing about interval notation is you got to know if you're using a square bracket or a parentheses. The main difference is if it goes to that point, you're using a square bracket. If it doesn't go to that point, you use a parenthesis. It's kind of the same thing here. If it didn't end at 5, you would just use a less than. If it does end at 5 where there's a dot, you're going to use the equal sign in there. So if it's an equal sign, you're using a square bracket like that. That's how those relate. And this is interval notation. I just want to write that over here. This is interval notation. And this one is if you want to use an inequality. So whichever way you like is up to you. The big thing here is that we just want you to know what's the furthest, what's the lowest, and the domain is to the left, and what's the highest, and that's to the right. For range, we flip it around. Let me go back to that one page. Range is always low to high, so we're looking down to up. What's the lowest value on my graph? Where, if I'm coming up from the bottom, where do I hit it first? Right there. So on the y-axis, -3, -2. Ooh, it hits at -1. That's the lowest point right there. What's the highest point? We're coming up from above, coming up, and we hit it right there. So my whole graph from down to up is between -1 and 6. So if we were to write that out, it's between -1, and this is the range, so this is the y's, and 6. If you wanted to write it in interval notation, it's very similar. It's square bracket. The lowest, is -1. The highest is 6. So those are your two ways of writing those out: inequalities or interval notation. This is also called set notation, but I didn't show you the full form. I just showed you the inequality because that's what's important for now. What's the lowest? What's the highest? All right, let's move down to these ones real fast. Here we go. So domain on this one. So here it's kind of hard to see, but these are arrowheads. So that means this graph is going to forever shoot to the right and kind of going up, and forever shoot to the right and going down a little bit. So first thing we're going to look at is our domain. So for our domain, let me grab these things. We're looking left to right. How far to the left does my graph go? Right there. How far to the right does my graph go? Well, if I hit this arrowhead's going to keep pushing me and pushing me and pushing me and pushing me. This graph is forever going to the right and down and right and up. So for domain, the lowest my graph goes, and I gotta look and see what that was again. I can't. The lowest it goes is -7. So -7 is the lowest my graph goes, and there is an endpoint there. And the highest my graph goes is actually infinity. It goes forever and always to the right. I gotta find where that is. Here it is. So that's how you could write that domain using inequality set notation. So -7 is the lowest my graph goes to the left, and those arrows means it goes forever to the right. That's infinity. For interval notation, the lowest is -7. The highest is infinity, and I do not have a symbol for that. Infinity. Now the difference that you see, that if you might have noticed it, is here I do not have an equal sign. That's because there's no endpoint to infinity. And if there's no endpoint, you use a parenthesis. Like if it doesn't go there, it's a parenthesis. And there's no end to infinity. So anytime you use an infinity, it's always going to be a parenthesis. If you see a point there, that means you're going to include it, which is a bracket, which is an equal sign. Next, come here, I want to grab that red line. Next is the range. The range is from low to high. Well, as I'm coming up to this graph, I hit this arrow, and this arrow, if this graph were to continue, this thing keeps going forever down and to the right. So will my bar ever hit a final stopping point? No, it will keep going down to the right. Whereas this one, there is a bottom bump right there, but this one's going to keep going down and down and down forever and ever and ever. In a similar story, it's going to keep going up. It's going to hit this graph, but then the graph is going to keep pushing it out as you go up. So this graph will forever go down and forever go up. So we got a couple ways of writing that. You can say this is negative infinity less than y less than positive infinity. That's if you want to use the inequality. If you want to use interval notation, it's parentheses, negative infinity, comma, positive infinity. Another way that you could even write this is if you're covering all the way from negative infinity to positive infinity, you're covering all real numbers. So you actually got 3 different ways that you could write that problem right there. All right, and now for our last one, we're going to look at this guy here. So the domain, again, is the x values. So how far left, how far right does my graph go? Well, if I take this thing and I hit this, oh, that's an arrow. That means this graph is going to continue forever in this upward and left direction. So do I have a left stopping side? No, I don't. This arrow will continue to push it all the way to the left. Same thing with this one's going to keep pushing it all the way to the right. So what we got for the domain is we got all real numbers again. All real numbers. If you wanted to write it with interval notation, that's going to look like this. The lowest is negative infinity. The highest is positive infinity. You would draw those little circles, but I don't have that ability with my brains right now, or with my mouse. If you wanted to do it in an equation, it's negative infinity is less than x is less than positive infinity. So all three of those, oops, just want to make that a little bit smaller there. So all three of those are representatives of that graph's domain. Moving on to the range. So the last one here. So how far low, what's the bottom point of my graph? Looking at the y-axis here, I go all the way down to 2. There's no graph below 2. This is all empty space. And what's the highest I go? Well, when I hit this, again, it's an arrow. This thing is going to go forever up and up and up and up and up and up. So it's everything from 2 to infinity. So the lowest is 2, and we do hit 2, so we're going to include the equal sign. This is the range, but the highest it goes is infinity. Interval notation is going to look like this. The lowest it goes is 2, the highest it goes is infinity. Always use in parentheses with infinity. So there's our super fast intro of domain and range. What we're going to do is we're going to practice on page 13. So go through, try some of those, and we will come together as a group. Thank you.